All right, I think we can start. Good afternoon, everybody. So I'm very happy to be back here at RTR for a very interesting session and also sort of a key session to work and activities taking place on CCAM. My name is Suzanna Kraak. I'm a policy officer working at DG RTD on connected and automated mobility. And I will quickly introduce to you today's session and speakers and also projects. And after that, we will hear in a little bit more detail 3 presentations. And also we will have a rather big round of Q&A, because we do have some time, which will be moderated by my co-moderator today, Margriet van Schijndel from TU Eindhoven. I see some people coming in, but we'll just begin. CCAM on the roads. So this is really the ultimate goal of all activities taking place on CCAM, at EU level, at national level, at global level, and also of all stakeholders combined. How can we safely deploy connected and automated mobility in real-life environments to cater to real needs and also to real challenges? And so how can we actually provide innovative solutions in mobility that are sustainable, that are accessible for people and also for goods? So here I'd like to quickly reflect on the work of the CCAM partnership, whose actual goal this is. So moving from the building blocks towards maturation of the technology, towards really the third phase of the partnership, which is the implementation of large-scale demonstrations. So these demonstrations should be of user-oriented and of well-integrated CCAM solutions for the mobility of people and of goods in at least 30 sites across Europe by 2030. This is the objective. And so this objective, of course, does not come without any challenges. Smooth integration into the traffic, smooth integration into the transport system, public acceptability, having also a very sort of diverse value chain to take into account. There's enough challenges to go around. And so we need to ask ourselves, how can we leverage R&I to answer to these challenges and also scale up solutions? One answer is, of course, by testing and demonstrating in real life conditions and in real traffic, looking at the practicality also of different use cases, expanding the ODD, harmonizing methodologies, looking at long-term impacts, and so much more, which our speakers today will happily discuss during this session. So together we will look at main gaps, also some challenges that they have identified in their projects, also results that they have achieved, and also recommendations, of course, for that they have for future research activities. And I am also especially interested in hearing about the commonalities between those 3 projects in order really to pull these together and to strengthen our upcoming research and innovation activities under our Horizon Europe framework programs, as we aim, of course, towards deployment readiness. So without further ado, we will hear today from projects Show, Award, and HiDrive, who will each have 15 minutes for their presentations. And so first off, we will start with the Show project, which is really one of our big projects looking at CCAM for urban mobility. This will be presented by John McSweeney, who is a project coordinator at UITP. John, up to you, the floor is yours.
Good afternoon, everybody. Oops. Good afternoon. Thanks for joining us. Thanks for the invitation to present Show. So yeah, I joined UITP in March of last year as a project coordinator for Show. UITP is the overall coordinator. So very quickly, Show in a nutshell. It's a research and innovation project funded under Horizon 2020. The object is to support the deployment of shared, connected, and electrified automation to advance sustainable urban mobility. So that really means within public transport. Coordinated by UITP, technical management by CERT. It's a big project, 66 partners at the moment from 13 countries and about 30 million euro in funding. We started in January 2020, which is not an ideal time to start a project looking at real life operations. We will finish in September of this year, so obviously we're doing a lot of work now on the final analysis and deliverables and the results. The objectives. I'll talk through the 8 big objectives that we have in Show and then go a bit more into detail of those or some of those in the results section. So the first objective was the identification of the priority use cases for automation in urban mobility. Started with 23 use cases. We've rationalized that a bit. We're working on 17 at the moment, and they're grouped under 3 large headings of automated mobility in cities, targeting passengers, mixed automated mobility in cities, And then additional services that CCAM can offer in urban mobility, things like parking assistance, depot management, issues like that. We're also looking at new business models for automation. We've got 10 business models identified at the moment. Those are being validated and tested along with the use cases at the pilot sites in the project. So the underlying assumptions and the expectations of the business models are being broken down and then being validated with survey data, with vehicle data, with simulation and modeling that's being done, and with the real life experience at the pilot sites. Then we have the common system architecture. So these pilot sites are generating vast amount of data, obviously. So we've got a common kind of data repository and interface procedures, the kind of main output of which is a show dashboard. You can consult that on the show website. And that is key performance data from all of the pilot sites that are running in the project. Behind all of this, of course, this data is being crunched continually to support the analysis of the business models and the use cases. Then we have improved vehicle functionality. We've got about 80 vehicles of all types across the pilot sites, some retrofitted, some commercially produced shuttles. Obviously, the retrofitted vehicles and research vehicles are the ones that undergo kind of more continuous upgrading, I'd say, but even the more commercially produced vehicles have been improved throughout the project. At the Karlsruhe pilot site, we had shuttles running on virtual rail at the beginning of the project. They obviously ran into some issues with obstacles in their path, badly parked cars, things like that. And so the local partners were able to upgrade the shuttles with the OEM's involvement so that they can deal better with those kinds of situations. Then we have the big objective of show, and that is the deployment of these demo fleets across, or demo fleets and the connected services and infrastructure across pilot sites. I'm going to come back to that in a lot more detail in a minute, so I won't spend time on it now. Obviously, once you've got these deployed, we're assessing the impact at a city level, but we're also looking then at the replication beyond shows. So we have follower sites who are it's kind of a matchmaking process between those. There's cities who are at kind of various stages of their path towards CCAM deployment. So they're being matched with the show pilot sites so they can kind of learn directly from people who are doing the work now of how they can kind of speed up their own deployment. We've also got replication activities at kind of a broader level, at a regional level with clusters of cities who are moving towards CCAM together, but also targeting OEMs, public transport, the kind of wide variety of stakeholders who can replicate what they're learning in show in their other activities. And then finally, we have and will have guidelines, a roadmap, and policy recommendations based on everything that we've learned from the very first use cases to the business models, to the impact assessment and the analysis and all of the data that we're generating. So, some results. As I said, we're in the last 7 months of the project now, so we're doing a lot of the analysis and the data crunching at the moment, but I can talk about some of the achievements already. So, as I said, we've got 80 vehicles of all types across a range of pilot sites around Europe. You can see retrofitted vehicles, robotaxis, we've got delivery robots, and these are operating in real-life conditions, carrying real passengers, serving real demand. They're operating on open roads, either in mixed traffic or in dedicated lanes. They're on closed industrial sites, they're in urban areas, some are in rural areas. And the real thing to stress, as Suzanna said, is that it's satisfying a real demand. These are real life operating conditions. They're obviously, as I said, generating massive amounts of data, and they're testing these varied use cases and business models. So a couple of the ones that jump out are the Frankfurt pilot site. There we're testing a first and last mile service in a residential neighborhood that was traditionally underserved by public transport. So the north of this neighborhood, you've got a public transport hub. In the south, you've amenities, supermarkets, doctors, things like that. And then the shuttles are operating an on-demand service that connects that area. It's proved incredibly popular. There's a retirement village kind of in the middle of that neighborhood. They're super positive about it, big adopters of the technology. The local PTO was already running a on-demand service with drivers in a vehicle already. So they saw this as kind of a low-hanging fruit that they could tackle as a first step towards rolling out CCAM. In Madrid, we're testing a very interesting use case in terms of depot management. So obviously at the moment, driver finishes their shift with the vehicle, bring the bus back to the depot. They have to take it from servicing to refueling to cleaning to parking. It's a lot of time, a lot of the driver's time. The use case here is, what can we do if the driver can bring the bus back to the depot, flick a switch, and the bus takes care of itself thereafter. A lot of interest for that from public transport operators. Depots are complex, busy environments, obviously. Space can be tight. It's quite a challenging area, but also as a closed, kind of contained site, you can do the necessary infrastructure work a bit more easily than on open roads. And then at Les Mureaux and shortly at Escren, we've had or will have fully driverless operations with remote supervision. So at many of the pilot sites that we've been running on open roads, local permitting required that we had onboard safety operators on the shuttles. At these two sites, we're able to go fully driverless, so no onboard safety operators or supervisors, and fully remote supervision. That's obviously a massive step forward, and there's a lot of real practical learning to come from that in terms of how do you organize remote supervision policies, what are your intervention kind of frameworks, how do you work with local partners if you're not going to have somebody present on the site to turn the shuttle on in the morning, to plug it in the evening. So real kind of like practical learning in how to organize all this. Moving on then, so I mentioned the replication work that we're doing within Show. There's 3 levels of the replication. First, we have these follower cities that I mentioned were being match-made with Show pilot sites. We've been organizing workshops, visits to the pilot sites, so they can get a real practical hands-on experience of how CCAM can be rolled out. We've also got the regional level replication, clusters of cities and municipalities, and also the stakeholder and operator level, like I said, OEMs and other partners within Show who can take what they're learning here and apply it either in commercial operations elsewhere or in follow-on projects. We're also working on sets of guidelines separately for industries, for cities, and for the public transport sector. And these are, kind of practical guidelines based on the learnings from the pilot sites of how to roll out these services. We've already produced some regulatory recommendations. I appreciate that's quite difficult to read, but this is in deliverable, I think, 3.3, which you can find on the Show website. And these are recommendations aimed at local level, covering things like physical and digital infrastructure, kind of fair access to the market, and pricing and revenue. So you can find like detailed explanations of all that on the Show website. These recommendations, the findings from the guidelines for the operators, for the cities, and for industry, all of that will feed into a EU roadmap, which we'll produce, and the vision of the roadmap will be how to deploy or fully deploy inclusive shared CCAM in an urban environment by 2040. Accompanying that roadmap then, there will also be various policy recommendations, and it'll be kind of a matrix approach, recommendations from the local level like this to the EU level, split across questions of operation, about revenue and financing, about permitting, kind of everything that we need to get this stuff on the road. CCAM operations, obviously, they're a global affair, so there's a lot of emphasis in the Show project on international collaboration. We've got great collaboration going on with the Cool 4 project in Japan under 3 big headings: AV behavior, regulatory issues, stakeholder perception. So we've been organizing workshops to exchange with Japanese colleagues what they're doing, where the commonalities and the differences are. On the stakeholder perception, we're doing an interesting study at the moment on user acceptance survey results from sites in Europe and sites in Japan that are quite similar, and we think there can be some interesting analysis there as to kind of, the kind of public attitude towards CCAM operations across different jurisdictions and across different cultures. With the US, we've had great collaboration with the University of San Francisco. Obviously, they're closely tied in with the work that's going on in that city in terms of CCAM operations. We've had a webinar with the Department of Transport. And with China, we've had an MOU with the Beijing Jiaotong Technical University. And there we're working on a comparison of approaches to business models between Europe and China. That's something that we're doing at the moment, so I don't have a lot extra to say about that, but that'll be an interesting analysis that'll come out at the end of the project. And of course, we are linking with other key projects going on at an EU level. UITP and many other partners within SHOW are also involved in the Ultimo project. One of our follower sites is also a site in the Ultimo project. We're involved with FAME and all the work that's going on there. And we've tied up with some other projects through the Horizon Results Booster to produce a policy brief. So really the kind of objective is that all of this learning, all of these recommendations are going to be discussed and tested with as many of the kind of stakeholders in the industry as we can, and also kind of maybe not benchmarked, but like that are kind of described within a kind of global perspective as to where CCAM is and where we can go with it. The impacts. So we've got 87 different KPIs in the project. Some of those are very specific, of course, to the operations at the sites, hard braking, average speed, things like that. But there are more broader level impact analysis that will be done on societal issues, including employment, on user acceptance and accessibility, on traffic efficiency, energy efficiency, and on environmental issues. And then to wrap up, the broader impact. Of course, the broader impact we're aiming for kind of coincides with what we think the use case for CCAM is within public transport. So we want real life, real world data that supports the business models and the use cases for how CCAM can strengthen the public transport network. And through strengthening the public transport network, leading to a reduction in number of cars and the number of kilometers traveled in urban environments. As I said, the data that's being produced that can produce best practices, cost efficiency, lessons learned for operators, for cities, for local authorities, for regional level administrators. And then the regulations, guidelines, decision-making mechanisms that can speed up the deployment of CCAM within public transport. And obviously then the direct exploitation, replication at other sites. So that's SHOW maybe a bit more quickly than I expected it to be, actually. There's a lot going on there. It's, as I said, 66 partners and 15, 16 sites around Europe. It's there's a lot of detail. We're doing everything from the analysis, impact assessment, user acceptance, technical development. There's a lot there. If you've got questions, if you want to get involved, if you want to team up with some of the pilot sites, we don't have a lot of time left, but we are super keen to hear from you. So yeah, get in touch. Thank you.
Thank you very much, John. For the people maybe in the back, there's still some nice seats here up front for a first-hand experience of the panel and the session, if you want to. In the meantime, John, I just have a quick question for you. You mentioned 80 vehicles, that's a lot. You also mentioned more than 80 KPIs, that's also a lot. And maybe just one quick question, how do you monitor these KPIs?
I don't. I leave that with my technical manager. We've spent a lot of time, even before I joined the project, kind of on setting up the kind of data exchange framework so that all of the sites are reporting common KPIs in a common way in terms of like the vehicle performance, hard braking, incidents, average speed, things like that. So they're all being produced and to this SHOW dashboard. So a lot of them are kind of stored there. So there's a lot of work went into making it a kind of a common framework, and that was kind of the key element to it.
And accessible.
Yes.
Okay,
yeah.
Excellent. All right, so now we will move on to the second project, so Project Award, which looks at automated logistics operations and demonstrations in adverse weather conditions. And for this, Natalie Teer, Strategic Affairs Manager at Easy Mile, will present the project to us in more detail. Natalie, you're on.
Thank you very much. I'm here to present the award project, which basically means all-weather autonomous real logistics operations and demonstrations. That means that we basically automated 4 different vehicles, which we're going to take a look at in a second, to, as the word says, operate in real sites for real use cases. Easy Mile is the project coordinator of the consortium. I'm not the project coordinator in person. He has to be in Norway for that specific project. But I'm quite familiar with it, along with 28 other partners and a budget of 26 million euros. So what we did in award, or what we're still doing because the project is ending mid this year, is basically to automate 4 different types of vehicles for 4 different types of use cases. So the first one being a port use case, so to automate a port trailer or yard truck. The second one is hub-to-hub logistics involving public roads. The third one is to automate a airport ground handling vehicle, which is the third one you see here. And then the last one is an automated forklift, which I found to be very interesting. For that, we obviously had to further develop the autonomous driving systems with, I'd say, 4 overarching goals. So the first one is being able to handle all those different types of scenarios and environmental conditions. So that means the use cases as well as the weather conditions, so rain and snow. We're going to take a look at that in a second. The second one is, of course, being as safe as we can. So for some parts of the system being or really targeting compliance with the ISO 26262, and also taking into consideration some SOTIF standards and recommendations. And then also integrating into the automated system teleoperations to be able to handle situations that maybe the automated driving system was not set up for yet. And then last but not least, obviously, also the fleet management that is very different in all these sorts of use cases. So as I said, we did that with 4 different vehicles. And now we're going to take a closer look at the use cases that we addressed. So the first one we're going to take a look at is the airport use case. So we did that at the airport in Oslo. It's still running, actually, where we automated this little fellow down there, the TLD vehicle, with the aim to manage luggage or to carry luggage from a point A to a point B and back, and to be able to run also next to airplanes, which is quite challenging, actually. So we did that on the route you can see down here. So basically, we had a waiting mission point, which is the one on top. The vehicle was driven manually to a start auto mission point. It picked up some empty dollies on the way, went all the way down to the container storage along that blue line in automated mode, and then went back with the dollies where it ended. And we did that under simulation of rain as well as snow, but the snow condition testing is still going on. So all of that was quite successful until now, and it's also very useful for us to develop the system because we're able to collect data from all the sensors involved, so from radars, LiDARs, and the cameras to further develop the system for all our weather conditions. So that was the first use case. The second one is the hub-to-hub use case, which I found was very interesting as well. So we basically took a CAMAG vehicle, which is a special purpose vehicle, a very heavy one, automated that and tested it in 8 different scenarios along a public road as well. So the entire route was from the Rotax engine production to the DB Schenker Logistics Center was around 600 meters, and it involved 200 meters of public road, so mixed traffic conditions there, and normal, low, and no traffic at all, and traffic intersections as well, which you can see marked in green there. The traffic intersections had one technical specialty, I'd say. They were equipped with CITS, so connected traffic lights, which definitely helped to handle some difficult situations because we encountered some challenges along the way. One of them being that at night or in the evening hours, people would just ignore the red lights. So since there was not much traffic on the grounds, they would just cross the red lights. So it's very important for the vehicles to be able to communicate with the infrastructure to also be able to safely handle those type of situations. Another challenge that we encountered in that use case is actually the speed of the vehicle. Since the vehicle is very heavy, it doesn't run very fast in general. So operated by a human being or by a human operator, it operates at around 16 kilometers per hour average speed. And the automated system was able to run at 7 kilometers an hour, which obviously is not very fast. So there's still some room for improvement, but it did so very safely. But in order to be more efficient, obviously in logistics, the system will need to operate a bit faster. The operations ran for 2 months and were as well tested under rainy conditions successfully. So the third use case that we addressed with a Terberg vehicle was the port use case. That use case was aiming to simulate all possible operations in the port and was therefore split up into 3 different phases. So the first phase was to move trailers from A to B around the port safely without loading and unloading a vessel though. The second phase was that the vehicle had to go to a public road to basically do the last mile delivery on a port. The interesting thing about that is that the vehicle had to automatically handle the barrier system that is basically embedded in the fleet management system as well of the ports. So it did that successfully as well. And then the third phase was the most challenging one, was to actually unload and load a ship. So we had to autonomously drive into a vessel, and that was especially challenging because we lost localization in the vessels, so there was no GPS tracking, so no redundancy in the localization, so we had to find a technical workaround for that, which we successfully did as well. And this is the point where I hope that the video is working that I brought to show you how the truck, nope, it doesn't. That's a bummer. Okay. All right, so the truck drives autonomously into a vessel. That's what you would have seen in the video if it had worked. But it is on the award website as well if you're interested in seeing it, as well as the hub-to-hub logistics use case as well. Now coming to the last use case, which is the forklift. That was conducted in Austria under snow conditions and rain conditions as well, and was also split up into 3 different phases. So phase 1 was basically to just automate the forklift because we've never done that before. and to have it safely operate outdoors. So there are forklifts that already run indoors in logistics centers, and they do that very well, but outdoors it's much more complex. So we automated that forklift for the outdoors in the first phase. And then the second phase was to autonomously load and unload a predefined pallet. So it was basically put there. The truck, the forklift had to pick it up autonomously, drop it off at a prefix point under snow conditions as well. And now the third phase is currently running. That is to load and unload autonomously an entire truck. So that's the most challenging part right now. And it's also doing that under rain and snow conditions. And one particularity of that case is that in all the other vehicles we have safety operators in the vehicles because they have cabins. This one doesn't, so it's remotely supervised. It's not teleoperated like in the hub-to-hub case, for example. It's really just remotely supervised. So these are the 4 use cases that we address with all the challenges that came with it, but also all the impacts we're already and the key results we're already taking away from them. So as I said, the project has not yet ended, but still we already came up with definitely 5 main key exploitable results and impacts of the project that we see for all the project partners. The first one being that through all those use cases, all the members of the consortium were definitely able to define the end user's requirements and the constraints that come with all those use cases a lot better. So to understand what the end users and the customers want, what type of challenges come with the use cases that they want to address through automation, that's definitely one key takeaway and one impact for all the consortium partners. The second one is that through the award project we were able to really develop a autonomous system or autonomous driving system that is scalable and safe at the same time, and that basically goes along with the third key learning, is that for the ground handling vehicle, for example, we've achieved the CE certification, which is very important to be able to run on industrial sites. And we're also trying to achieve that with the port yard truck by 2025 to be able to run on ports. The fourth key result for now from the project is that those vehicles are now able to run 24/7 in real logistics environments. So for example, the EasyTow is already running at a BMW plant and also a Daimler Trucks plant in 3 shifts, 24/7 on 5 days a week. So I guess that's a pretty big impact and achievement. And the last one is that through the project we were able to come up with basically 2 safety frameworks for one ports, so autonomous vehicle driving on ports, that we developed together with the authorities of the Port of Rotterdam. And the second one, going along with that, is a safety framework for airports that we developed together with the DGAC, which is the French authority for airport security, for AVs to be able to run in operations safely on airports. So that's the 5 key takeaways from the award project, and I'll leave you with that. Thank you very much.
Thanks a lot, Natalie, for this presentation. Maybe just one quick question also for you, because it's one of the final slides that you showed, talking about the use cases. You mentioned the usefulness of these use cases for the partners in the consortium. Maybe you can talk a little bit more about that, maybe if there are any sort of main positive or constraints that they found really in looking at these use cases. And also another quick question is: were there actual customers involved in these tests and in these demos?
Well, not yet real customers, but probably customers to be at some point. So, for example, the Port of Rotterdam, after seeing the demonstration in another port in the Netherlands, we're very much interested in implementing that technology in the port as well. So I think that's where we see the real effects through the project. Yeah.
And the scalability as well of these solutions.
Yeah, definitely. And as I said, the CE certification, for example, that we achieved with the ground handling vehicle was one of the most critical parts, because you need that to be able to run on industrial sites and airports and ports. It's just a requirement that they have, and to be able to have a scalable product, you need safety frameworks and CE certification.
Excellent.
Yeah.
Thank you so much. So now we're closing off our presentations with the HyDrive project, which is also a big project from the Horizon programs that looks at achieving higher levels of automation in various use cases as well. And so Natasha Merat, Professor of Human Factors at the University of Leeds, will share with us some latest insights. So Natasha, the floor is yours.
Thank you, Susanna. So like Natalie, I am not the coordinator, I'm the second in command. So the coordinator's having a nice time in a hot place right now, and somehow I got roped into doing a presentation. But that means that some of it will be his kind of work, but a lot of it is my work, which is on human factors. So slipping into tomorrow's session already. I hope you don't mind. So the idea behind HyDrive is to develop an understanding of the user when interacting with automated vehicles, or at least what I'll be focusing on. I think we had a different slide, but never mind. So this is one of the key pictures that we use, and it's thanks to our friend Tom. You should have trademarked this before it came out. We didn't pay it for it, but he had a presentation a while ago where he said automated driving is not going to work because we just keep stopping and starting. We start, and then for various reasons, it doesn't carry on. And guess what? That became the idea around HyDrive. I don't think you've got all the credit, but anyway, it was a nice idea. So looking at how can we make that journey nicer, easier for the user. This is now different to the previous presentations in privately owned vehicles. So we're looking at cybersecurity, we're looking at interactivity, connectivity, and hopefully user-aware vehicles, so that, for example, if there are vulnerable road users around, how does the automated vehicle deal with it? So, what have I done?
Just go out.
Okay. So, some project facts, 60 million euro budget, 30 million funding. We're sort of almost halfway. We finish in June 25, 53 partners and 13 countries, and it's supported by UCAR and the Commission, so that gives you an idea of who we are. And here are all the partners, so major OEMs, as well as research organizations and universities, and organizations such as FIA, who are really helping us with engaging users to understand what these automated vehicles can and cannot do. So just a quick overview of the concept. So these are basically the sub-projects. So we have sub-projects on enablers. So this is the connectivity, etc., that will allow that disconnection of the OGD to be connected. We have been looking at the methodology to create the vehicles to test our research questions, and the vehicles are currently running around in an operations sub-project. We have the user sub-project, which is what my speciality is. And finally, we're looking at the impact of these in terms of impact assessment effect. We have outreach activities, so working across the world with various standardization, user education, etc., organizations, and also collaborating, part of, for example, twinning with various US colleagues, and looking at these various technologies, functionalities, as you see, also across different borders. That's particularly challenging going from one country to the other. The UK is not involved in that one, by the way. As you can imagine, there's a big bit of water in the middle. Okay, so going swiftly into what I'm doing. So the sub-project that I'm looking after, and I always have to say, it's the first time this consortium, which has been running for 15 years, has agreed to have a whole sub-project on the user, which is really nice because it's a realization that we need to understand the user and the human, otherwise it's not going to work. So we have 4 main work packages looking at users' acceptance and awareness and expectations of the automated vehicles, their comfort, as more and more of the automation of the driving is done by the system. How can we make sure that people are comfortable in it? Looking at user monitoring and human-machine interfaces, and also, as I said at the beginning, the interaction of the vehicle with other road users. So in a bit more detail, we need to understand a large group of users. So ideally, young people, older people, different ethnicities, cultures, etc. As I said, looking at acceptance and awareness of the vehicles, comfort, and whether or not people are going to feel ill in some of these. And there is some evidence that even in electric vehicles, because of the way they speed up, people are feeling a bit more ill than the normal traditional ICE vehicles. And then finally, interacting with other road users. So we've basically, we finished looking at the research questions about this time last year, where we set out literally hundreds of research questions, trying to understand what are the things that we need to test in terms of acceptance and awareness. And this has involved user questionnaires that are given to people as they are getting in the normal automated vehicles before and after, but also a global survey to get a feeling, and this is a sort of longitudinal study which started from the L3 pilot project, where we're looking at what do people understand about these things, what do they want from them, and this is going through sort of Europe, US, China, etc. So really getting an understanding of what the global understanding and awareness is of automated vehicles. In terms of external road users, we're looking at how does the pedestrian and cyclist understand what the vehicle is doing? Is it just about the way it's driving, or do we need some kind of explicit communication, some kind of lighting or sound or whatever for the vehicle to communicate with other road users? We're looking very deeply in terms of the onboard drivers and the passengers. I've mentioned comfort and whether the vehicle needs to be driving more like a human or more like a machine in order for it to be comfortable, and how does that relate to car sickness? User monitoring is a big area. Those of you who are maybe involved in standardization, Euro NCAP, etc., already vehicles have to have some kind of user monitoring to know whether the driver is fatigued or distracted, etc. And obviously more and more control given to the vehicle means that more and more the driver is going to be fatigued and distracted. And so we need to look at, how can we keep the driver engaged, and also the human-machine interfaces to do with that. And then finally, looking at teleoperators. This is, I would say, relatively new, but it's gone in terms of interest. So when we started writing the proposal, everyone was like, teleoperators, human factors? No, don't understand that. But then suddenly, of course, maybe thanks or no thanks to Waymo, Cruise, etc., and actual companies doing teleoperation, we need to understand what are the human factors of teleoperators, and some interesting studies there. So we, as well as the OEM vehicles, obviously not everything is possible in the real world, especially for higher automated levels. So we have a series of simulators, but we're also doing Wizard of Oz studies and actual on-road studies. In terms of user monitoring, we're looking at, we're working with various companies who supply these, as well as the partners themselves who are developing these camera-based user monitoring systems. And then finally, some videos there of interactions. So at the top, external human-machine interface in terms of a light. In the middle, you can see a pedestrian simulator where basically the pedestrian is walking and interacting in virtual reality with an automated vehicle. And on the kind of external communication, we include the remote assistance. So we are not there yet. The partners are very, very busy data collecting, but we were asked to provide some results. So some initial takeaways for you. So in terms of external communication, some kind of information like a light or whatever does help to improve the crossing initiation time. So when people know what the message means, they cross a bit earlier compared to when there isn't external communication, and they like it, they trust it a bit more, especially in what I've called uncertain situations. So when there isn't any infrastructure-based information, so no lights or zebra crossing, jaywalking type situation, it seems to be useful to have some kind of explicit communication, but the two go together. So we, unlike what we thought, we as humans use the behavior of the vehicle, how far it is from us, how quickly it's stopping, to tell whether or not we should cross. So that's in addition to some explicit communication. So the scenarios need to be developed more to decide when each is required. And actually, if you don't do it well, then people end up crashing because they see the explicit that says go, and they use that rather than the implicit. So it needs to be done well. In terms of driver response, when I started this work about 15 years ago, manufacturers were like, just want to tell me how long will it take for people to take control? That's all I want to know. Well, I can tell you now, it takes about 3 to 5 seconds. But that's just a quick reaction time task. So if I give them a warning, they take control. That is not the same as the quality of that response. So they can stop the car, but if there is another car behind them, it will crash into them. So response time, very good, but actually thinking about what to do, totally different aspects. So we've also been looking at distraction. There's this sort of concept, again, provided by UNEC, Euro NCAP, of cognitive load. So you are loaded, you're looking at the road, but maybe you're on a hands-free phone conversation or something, so your mind is somewhere else. That causes you to look just at the road center, so you don't look around as much as you should. You don't look at your mirrors, and you really sort of, your gaze almost freezes towards the road center, especially if you're older. So we've been looking at younger and older drivers, and that's particularly bad for older drivers, but it still doesn't affect that quick reaction time. It still does affect the quality of the performance. And then finally, some work on the effect of activities while you're in the car. So ideally, as you may recall, why is it good to have automation? Because you can do other things, but people are starting to feel ill when they do other things. So there's some work, really nice work by colleagues in Ford, who are actually looking at this on the road, and looking at different types of non-driving related activities. And the good news is that if you can reduce so it does make you feel ill, but there are ways that if you stop doing it, that you do recover relatively quickly. Okay, I don't know how much time I used, but just a snippet of the results. Thank you so much for your attention.
Thank you very much, Natasha. Just one quick follow-up question, maybe on my side. So again, in the last slide, you talked about the external communication, the implicit and also the explicit communication. Could you maybe, add some nuance to that? What is the implicit communication in this sense, and why is it so important to distinguish both?
Thank you. Basically, when we started this work, and Matthew may remember in City Mobile 2, there was really a belief that we as people use explicit movements and do things like go on and eye contact and head movements and that kind of thing. So we said, okay, when there's no driver in the car anymore, we need some kind of explicit communication. Now, that might be a light, a flashing light, I'm stopping for you, or something like that. So we worked on this actually in the Interact project, where we looked at the various messages, but the disappointing news or whatever is actually less than 10% of our interactions are explicit. What we do is we use implicit things like, basically, if a pedestrian does this, we as a driver very far away can tell, okay, that's a movement. Or if the car that's approaching does like a little brake, we can see that well before anything else. So we use the behavior of the vehicle much more than beeps and bops and lights and Christmas lights, as they say. But when you get to situations, sorry, this is a very long answer, what we call a standoff, and actually there's been many examples now where people are testing it on the road. For example, a cyclist and a Waymo car come to a crossroad in the States, and they're both not moving. That's when explicit communication is useful. So to sort of hit the kind of flashing lights or whatever it is that we use to say, okay, I'm stopping, you go. Understanding what that means, though, across the world is the problem that we need to address. Because, as I say, flashing headlights in the UK is unofficially you can go, but apparently in some other places you can't go. So
this is where these cultural differences also play a role, right? But you obviously need both to be integrated into the vehicle to understand.
Indeed.
They're both crucial. It's okay.
Yeah.
Thank you very much. So again, thank you to everybody who presented. We will now move on to the second part of our session, which is a Q&A. So we're going to also hear from you if you have any questions. And to do this, I will give the floor to Margriet, who will moderate this Q&A. And that's it. Yeah.
Thank you, Suzanna. I think we've seen three totally different contributions, having their own application domain, from urban mobility to heavy-duty automation and to understanding the user when interacting with automated vehicles. So the ambitions in the projects range from fairly technical issues to way beyond the technical issues, quite diverse, so it must have been quite much to digest for you. And though I think the presentations were quite clear, I really hope there are some questions from you. I can't believe if there aren't. Yes, I already see 2 questions.
Hello everyone, so thank you very much. I'm João from CCAM. My question is related to security. We heard about safety, but I see some autonomous operation in very security critical infrastructure like ports, airports. How do you guarantee security of data, of connection, and how is this a barrier to deploy such solutions in this very specific infrastructure? Thank you.
I didn't get the last part of the question, sorry, could you repeat that?
If it's a barrier to deploy such solutions in these critical infrastructures, if it's a barrier for them to accept such solutions, and how you tackle them. Thank you.
Okay, so I guess that is mostly directed at me, probably. All right. You're absolutely right. The critical infrastructure is definitely something that we're addressing. And as I mentioned, we developed 2 different safety protocols, but they also include things like cybersecurity, for example, and the fleet management that we connect with the vehicles, for example, through the port or together with the port authorities. So these are things that need to be certified. Definitely there's room for improvement, and definitely there's need for standardization and standard security and safety protocols as well here. But at the ports where we operated, and also the airports, we need to have a safety case, we need to present a safety case that also includes security measures. But it's true that on the scalability part, there's still room. Thank you.
Thank you, Nathalie. Sven.
Thank you. Sven Marivoet, Transport and Mobility Leuven. I have a question actually for Natasha. We know the HyDrive project quite well, and the fact that it runs for 4 years means we have to wait a long time. But in the meantime, you are in a consortium with a lot of OEMs, which by itself is already unique nowadays. We heard from all academia and public sector, like the takeover time before going to a minimum risk maneuver. Now, I've seen that you have put a number on the takeover time, but how do the car manufacturers think about this? What time do they give to the user or to the vehicle before? How much time do the car manufacturers give to the users before they put their vehicle in a minimum risk maneuver, and what does the vehicle then do, and how do your users react to this?
So, obviously, there's regulations around that, and for at the moment, for level 2, which is mostly what's on the road, the driver must monitor at all times. So there isn't any there isn't a requirement there, but then at level 3, I believe it's 10 seconds. Where that has come from is debatable, because we're still working on the science, so to speak. So, but of course, we need to have something if we're going to go forward. And as I say, 10 seconds is enough, depending on where it is, because it takes 3 seconds, right? 3 to 5 seconds to take over. So I think what I've seen from level 3 vehicles is that the driver monitoring system does not allow you to look down long enough for it to go to that 10 seconds and minimum risk maneuver. So that's where we are right now. So I think it's sort of working with that and working very slowly. And on the safety side, it's just not possible to do. I've not been in German cars that are have that and can go faster, but at least in the UK, it's almost, you just can't use it really, because you can, by the time it gets going, if you take your eyes off, it disengages. I hope that answers the question. Thanks for the tricky question.
No, thank you, Sven. And I think, Nathalie, you wanted to jump in, right?
Yeah, but I think Armin also has something to add, so it probably goes in the same direction.
Armin Greta, BMW. Maybe I can directly answer to this with the experience of having driven the car on German highways. Well, in fact, with all the redundancy and all the safety assurance systems and validation which we did for the car in the positive risk balance for the German highway network, for the whole function of level 3, we can say that you can indefinitely look away from the road as long as this system is available, and it's available through rain and night and normal conditions. No crossroads, no tunnels, no. So when it's the normal highway, it's available and you can look away as long as you want, and you have a reaction time of 5 seconds, which is regulated in the ALCAS regulation in Geneva.
Thank you, Armin. Any further questions? Yes, Horst.
Horst Plügel from AVL. I would be interesting for this critical area. So you said this should work under all weather conditions. Would be interesting what type of sensors are needed there. I don't know if you've mentioned that. And the second question, it looks all a little bit tailor-made to a specific situation. So what is if the situation changes, or if or you want to cover a new scenario? How easy is it to transfer that to a new situation?
Okay, so on the first part of the question regarding the sensors, so all of those vehicles that you saw were operated on LiDARs and radars. And further evolving the technology would also include cameras, which was not the case though for that one. But that would especially help for simulation. So to collect data, for example, for simulation through camera, to be able to, add some more rain in simulation and add the cameras onto that, but mainly they run on LiDARs and radars for the all-weather conditions. And all-weather means, for award especially, it was 100 millimeters of rain per hour. So beyond that, the vehicle won't be able to operate on LiDAR and radar alone. I'm not sure I got the second part of the question. So what type of situations or use cases would you mean?
It looks like the setup was there's a specific task to do, put that from there to there, and nothing, and no variability, let's say.
Oh,
so
okay,
if
I
the
see.
situation
Yeah.
would change, or if there would be a different task,
Yeah.
how much effort is this to transfer this function?
Yeah, so obviously, yeah, the technology has to evolve with that. So within software increments, we add more features to the technology to be able to address different types of situations or tasks. But in logistics, to be honest, most of the tasks are very straightforward and similar. So at an airport, it's bring the luggage from A to B to C, or even on industrial sites, is bring material from A to B and back. But within those tasks, to address different types of scenarios, that's actually the most interesting part, because you, I don't know if you've ever sat at an airport and looked at the traffic that goes around. It's kind of crazy, and it seems a bit unregulated, even though it's regulated. So, and then, I don't know, if suitcase falls off, so you have to have obstacle circumvention, for example. You can't just go on a straight line. You have different types of vehicles crossing. You have the aircraft, so it's very complex. So actually, these types of scenarios, it's what's very interesting. And adding additional tasks is not the most challenging technical part.
If I see correctly, I think you were also looking for the scalability of these solutions for different applications, and you indicate, right?
I think this was more or less answered, yeah, because you said, okay, there's some adaptation work necessary, but it's very flexible already.
Yeah, I'm wondering a little bit, because I was told, Frank Seifried, Volkswagen. I was told by my co-workers that weather conditions are the most difficult part for the control unit. First rain, even more difficult snowfall, and even more difficult foggy conditions. So the diffusivity of the signal increases the rate of errors. And therefore, I think weather conditions are extremely important.
So that's to confirm the relevance of such project, right? I think. Well, I don't think that you're going to disagree on that. Any further questions? Yes, Sven.
Yes, hello, Sven Jansen from Tino. Apologies for my questions in most of the sessions. This time a question also related to the MODI project. I was just wondering what kind of communication you had in award with, let's say, non-standard roadside equipment, and specifically the barriers, which are also a topic in MODI. And yeah, we were wondering what kind of recommendations you could give what kind of method or what kind of communication to use for that.
That's a very good question, which I'm not fully able to answer, I must say. I'm sorry. I know that the traffic lights that were installed at the hub-to-hub use cases were based on CITS, so it's a basic V2I communication infrastructure. But, and I I would say that probably was the same for the barriers at the port, but I'm not sure. So if I may come back to you with a more satisfying answer, I would love to do that.
Perfect, thank you for that. And maybe we can put that also in the summary of the session so everyone can see the answer as well. So, any further questions? I'm now at the back. Yes, Jarek, sure. How could I overlook you? Sorry.
Thank you for coming all the way. Sorry for sitting in the back. Sorry also for not saying hello. Natasha, question to you. Hey, for the cognitive workload, I have to say that.
Jack, can you come a
sorry.
bit
My name is
closer
Jack Krotzinger.
because
I work for Toyota Motor Europe.
Yeah.
And I have a question related to the topic on high drive cognitive load, because in one of your last slides, Natasha, I saw that you were saying that the gaze behavior changes with age, so that coming back to being responsive on a higher quality changes with age. If I read between the lines, then that means also to me that gaze behavior alone cannot tell me enough about cognitive workload.
gaze behavior is what, sorry?
Gaze behavior cannot tell me enough about my cognitive state of mind.
Yeah, this is actually what we're doing with you guys. So if you're around, we're doing a presentation next week on this. So gaze behavior, well, there's very strong evidence that when you're thinking, your eyes don't move. Do you agree with that?
At the moment, I'm looking at you and I'm thinking very carefully. So at the moment, I would say
and
no.
Driving. And driving. So basically, your eyes freeze when you're thinking. One thing. Second thing is, and it's very interesting, one of my students just presented some gaze data, and it reminded me all the way back to my first supervision meeting where my professor said, how big do you think that elephant is? And I looked up and left. That's the other thing that happens, is that your gaze really can tell you a lot, actually, about what people are doing. The old-young thing, and maybe we can discuss this in more detail afterwards, is basically the fact that as we get older, we're not very good at multitasking. So again, for our both groups of drivers, they were doing actually a very difficult memory task called the NBAC. You might be familiar with it. And the older drivers in particular, their gaze was more frozen, so to speak, than the younger drivers who were looking around a lot more. Obviously, this is driving simulator studies, it's a one-off kind of thing. There will be differences as you get more practice, etc. But I invite you to think about it yourself if you're naughty enough to do a very long conversation on the phone. What that sort of, whether you remember seeing, you go through the traffic because it's automatized and it's a green light, you go through it. But do you remember doing that? That's what we're sort of trying to show, and we are showing very, very strongly in manual driving and automated driving.
But affected by other parameters like age?
Chuck, can you, I've got a hearing impairment, so can you speak very
I'm
clearly?
sorry, but it's also affected by other parameters that might affect it, like age.
Of course. And it's maybe something we need to talk about, as I am aware of your work in that area as well.
Absolutely.
So,
I'm hugely interested in that. Thanks.
thank you.
Thanks you. So, Chark, you were looking for a yes/no answer, but you got a more complex answer and more than you need.
That's what I like with Natasha.
I know.
Thank you.
Magnus.
Yes, Magnus Granström, Safer Chalmers. Continuing a bit on that question, because now we primarily sort of talked about age. So again, Natasha, do you see any major differences between professional drivers and casual drivers that you would like to comment on?
We are looking at that right now, not in high drive, but another PhD student of mine who's looking at racing drivers actually, and other drivers and how they direct their attention. So obviously with experience it gets, you know where to look for more as you become more and more experienced as a driver. I think it's complicated. So professional is different from experienced. So that's really important to make that distinction. So I don't want to sort of encourage 40-something-year-old people who are experienced drivers to think it's okay. So you need to actually have training. And I'm aware, for example, that highly trained drivers, how they look at the mirrors, etc., and I've seen them actually do that. It's very different to how you and I drive. So that's a separate distinction again.
Thank you, Natasha. I see another hand in the air from Armin.
Yes, thank you. I don't want to add to this one, but it's a very important and interesting topic, and we need to work much more on that. I fully agree. But I have a question to show. The KPIs which were mentioned, will we see at the end of the project a kind of summary explaining in detail about the KPIs around safety and convenience? So I'd like to understand better what of these, let's say, early urban level 4 use cases really had safety issues, and how big was the convenience for the users. This would be, I think, the most important result from show.
Yeah, so there'll definitely be both of those covered. On the, sorry, you said safety and the convenience. So yeah, on the safety side, in terms of there'll be impact assessment in terms of the vehicles and their performance themselves, and things like hard braking and any incidents like that, incidents with other road users. There'll be something specific on interaction with vulnerable road users. And on the convenience, yeah, there's survey analysis at all the pilot sites, kind of before and after in terms of attitudes. But yeah, those surveys also take into account people's willingness to pay, their kind of vision for like when they would use the service, how they would use the service. So I would say yes, it will all be covered.
Good. And another question related to show for you, John. I was curious, somewhere in the material you mentioned that your collaboration, your international collaboration, was very fruitful. Can you tell me what made it so fruitful, and what differences or similarities with US and Japan you have spotted?
So I'm not going to say much about the US, because a lot of that stuff was taking place before I joined shows. I can speak a bit more about the collaboration with Japan. I think what's been quite useful there is firstly just a very open discussion and sharing of experience. So the colleagues there have been quite ready to discuss where they are with their deployments, what issues they're facing. I think the most interesting thing for me from the public transport side is that I think we are reasonably far ahead of where Japan is in deploying these services in a public transport setting. But saying that, what the Japanese government have in mind in terms of deploying large-scale pilots in the next 4 or 5 years, they'll catch up quite quickly, I think, just with the volume that they're aiming for. So I think Europe has leadership. I got to experience a public transport pilot site in Japan last year. They're using European technology. That's what they're looking towards as the best stuff at the moment. So yeah, I think on the regulation side, they're also a little bit behind us. The kind of permitting processes that they have are super localized, where really like the local police chief needs to sign off on your plans. So we've had issues with permitting at some of our pilot sites in show, but not maybe to the kind of granular level that they're having to face over there. So there's a lot. I think there's a lot to be shared in that kind of area of the regulating and the permitting as well. Though it's there are definitely kind of cultural differences to the approaches.
Yeah, thank you. But I think within Europe we also have some cultural differences. So yeah, maybe good to take them into account anyway. Yeah. But thank you, John. I think you've had some time to think about your future questions. So who's next? Yes. That's good for my exercise and to stay awake in this warm room. Sorry.
Thank you. I'm Ragnhild Wahl from ITS Norway, and I also represent MODI project. It's a question to Nathalie, and coming back to the sensors and the all-weather part. All-weather is far beyond what award will showcase, I would say. But you mentioned the requirements for rainy conditions. But what about all the other weather elements? Will you define concrete thresholds, which we actually are managing today, and thresholds for where we would like to be, and the gaps?
I guess yes. I don't know if the project coordinator would agree with me, but I know that as a technology company, so speaking for EasyMile and providing the technology, definitely we need to do so, because I agree with the Volkswagen colleague who said that fog, for example, was the most challenging weather condition to address, and I fully agree. So with rain, we can handle quite heavy rain, and we can test that quite nicely as well in rain tunnels. We can simulate snow. We've been testing snow in Oslo, light snow to mid-snow. When it comes to very heavy snow, we're not there yet either. And I think that also means that the sensors, so not only the software behind it, but definitely the sensors and the sensor fusion needs to evolve. So we need to have more research and development in for the sensor sets as well, because we also see that the sensors that we're trying to find on the market, sometimes they're just not there. So for LiDARs, we're quite good. For radars, there's definitely room. And for cameras, we just need to work basically on the software that's behind it, so to further work on the AI that basically enables us to use that sensor.
Thank you. And I think maybe you need a more detailed discussion that you can learn something more in detail from the project. Natasha, you wanted to step in, right?
So yeah, I'm definitely not the technical person, so please just don't ask me any questions. But HiDrive recently demonstrated, in fact this time last year, in heavy, northern Finland, Lapland, we had some demonstrations of the technology there, and it was quite fascinating. I was in the vehicles, and heavy, very heavy snow, no lines on the road, etc. Quite impressive. There is a video, and I'm sure if you want to talk to our colleagues at VTT, they can tell you a bit more about it.
Thank you for that addition. Thank you. Further questions? Raising hands means a question, so David, I'd say making a picture, that's different, yes. You're getting shy at the end of the day. Not too shy yet. Tom, it would have been strange to have you in the room without any question.
Yeah, thank you. So I have a question. So when you reach the end of the ODD and you get a request for a takeover, well, I think it makes a difference whether it's expected or unexpected. Can you say something if it's an unexpected takeover, it is initiated, but the driver does not respond? Have you looked into any minimal risk maneuvers? Can you say something about that?
Yeah, that is a challenging one, and I have to say, I only recently came across the expected versus unexpected, because for me, if it's a high level of automation, I don't think there should be any unexpected. Is my answer. So of course things can fly from the sky, etc. And I think that's what makes level 3 perhaps more challenging than level 2, because at least with level 2 the user is monitoring. Level 3 they're not expected to monitor, and yet there is an unexpected event possible. I don't have an answer, unfortunately, regarding what can be done on that, but I think we're looking at places where it's less likely for these edge cases. I don't have an answer. I'm sorry. I don't know whether any of the OEM colleagues want to say more.
Well, I think that that's also related to research. We don't yet have all the answers. It's sometimes hard to accept, so it's very brave of you to admit that on stage. Thank you for that. I have a question also related to show and award on the responses that you get from local authorities and operators, thinking also on the longer term implementation after the demonstrations. How do they see that? How do they appreciate it, or what changes would they like? What discussions do you have with them? For both of you, so you can decide who starts.
So I mean, I would say it varies. I mean, I think most of the pilot sites that we have in show will continue in some format. Some will continue within other projects. They're moving to slightly more complex pilot kind of phases and demonstrations, more complex environments. A few will continue as commercial operations. I think the kind of marker is that there's real enthusiasm for it, and there's a real kind of vision at a local level between the public transport operator and the authorities, and they're kind of on the same page. I think that always just makes it easier. It's not one having to convince the other. But so far, I think the feedback is positive. People see these as valuable services that are expanding public transport networks into places that were underserved. They're a valuable tool, a valuable way of serving citizens. I think there's, of course, issues to be ironed out, but I think the bulk of the issues to be ironed out are at kind of an operational level on the part of the operator, and the ties with the OEMs, questions of maintenance and keeping the fleet on the road. Those are the kinds of issues. There's not a lot I've seen where we have an authority who has permitted something and are wishing they hadn't. I don't think that's happened so far.
And for you, Nathalie, the discussions with operators, for instance?
Depending on the different types of use cases, it's a bit different. But I would say that on industrial sites and airports, there's a lot of interest, and the same goes for ports, because one of the main factors we all know about, especially in logistics, is also the driver shortage and the shortage of just qualified workers that those industries need to deal with, and also the safety issue. I can't remember the amount of accidents happening on ports, but it's a lot. I was a bit shocked by the number when I first heard it, even though I can't remember how much it was. But the interest is there. We need to scale or to further develop the products, the systems to be really more scalable, and then I think that's where we'll probably first see commercial use of automated vehicles, definitely in the logistics sector, on private sites.
Thank you. Suzanna.
Yeah, my question is related to public acceptability, because this is something that we've talked about, and I think maybe in all of your projects, but maybe mostly in Show and in High Drive. I mean, very much so. The added benefit or the added value of having demonstrations is to be able to engage more with different users and to have an actual feeling of what they need, what their expectations are like, and so on. And so I kind of have a question: how you approach this more in your projects, and also maybe specifically in High Drive. Did you collaborate, for example, with local authorities to map these user needs, for example? And then maybe more for Show, again, similarly, how did you go about these acceptability issues? And a follow-up question even would be, are we looking only at users? Are we also looking at non-users? How do we, CCAM, it's not just sort of a solution for specific users. It's going to be, experienced by everybody. So how did you approach that? Lots of questions.
I'll answer the first one. So not specifically with road authorities for that aspect yet. I think that the conversations have been really about getting access to the cities to test the vehicles on the user side. But I think it is really nice to see that, yes, it's about managing expectations. For example, the work that FIA, etc., are doing with these sort of road shows where we're actually getting the systems to be seen, to be tested, to be looked at. And that's a big area, I think, a big hurdle, I think is the word. Again, there was a recent report, and there's a few reports such like that where basically there's lots of beeps and bobs happening in vehicles. People don't know what the systems are, what they do, how they can help with safety, etc. So the user education is absolutely relevant right now and going forward, because the systems are in the vehicle, at least for the sorts of work that we're doing, and people need to understand, and managing expectations is the biggest area in order to have them adopted, accepted, etc.
John, did you come across that as well in the show project?
Yeah, well, I mean, the show project, we had a slight advantage, I think, in that, the pilot sites are operating public transport services, first and foremost. So they're fulfilling kind of user expectations and needs that are known to a certain extent. So, to go back to that pilot site in Frankfurt, they're providing an on-demand service there already. The automation makes it a bit different for the users, and there's a lot to be gathered in terms of how they react to that, but the kind of basic need was known. I think, in terms of the reaction to it, we've got, some very interesting findings anecdotally for the moment, as far as I have, in terms of the interaction with the kind of the implicit, explicit communication at crossings and things like that. So people looking to the onboard safety operator for this sign that they should go. I think one of maybe the gaps that we have, which definitely needs more research, is the acceptability by other road users. Because we're concentrating on the acceptance by the users of the service. A lot of the kind of issues that we have on the road are with cars that don't want to be driving behind a shuttle that is limited to 20 kilometers an hour. And, I don't know the figures, but from my own experience, the hard braking that comes about is because somebody's overtaken on a very narrow stretch of residential road and the shuttle stops. So I think, the kind of acceptance by other road users is something that we need to do more on.
Thank you. You had a question as well, right?
It's for Natasha. I'm Gal, I'm from Correction. I want to ask about the driver monitoring method. I want to know if you thought about any criteria for what is impaired driving. That means that not checking each effect differently, but calculating all of the effect, like fatigue, alcohol, and cognitive load, and to see if, even if each parameter or state is not in the threshold, still the driver is impaired because of a combined effect of 2 or 3 states.
Question. I think everyone would agree that driver monitoring systems are not there yet to even distinguish between is it fatigue or is it distraction. So I don't know whether, for example, camera-based eye trackers on their own will be able to make that distinction. So the work is around other sensors, whether they be face-based or posture-based. Some of my students have found really nice results from skin conductance in terms of workload, where they're not seeing that necessarily for level 3, especially because people are not looking at the camera. So I think we are not there yet in terms of what you're asking, even individually, to be able to look at things across the various drivers as well. So it's in some ways it's only just starting, and definitely the driver monitoring or occupation monitoring colleagues that I'm working with in companies are absolutely acknowledging that it's tricky. I don't know whether I answered your question, but yeah.
Thank you. Yes, Mats. Oh, I see.
Yeah, it's Mats Rosenqvist from Volvo, also the cluster lead, cluster 1 for large-scale demonstration. And of course, my question is, what are your expectations for the coming program? I mean, what do you need, what do you like to see in future projects? So what are your expectations? Yeah, time to add to the wish list. So that would be very helpful. Thanks.
Well, you have his ear now, so yeah. John, can you start, please?
More public transport.
Sorry?
More public transport.
Okay.
I mean, at a basic level, more work on CCAM in public transport. I see Lars here. The Ultimo project is a great kind of next step from what Show was doing with larger fleets of vehicles in cities. We need more of that. I'd like to see more work on how we do the remote supervision of fleets of public transport, because that's ultimately where it needs to get to if this is going to work at a large scale. So I would just, in general, please more public transport in this sector, and yeah, the remote supervision. We need to start doing more of that.
What about you, Natalie? Because I think you didn't have any public transport use case.
Not in the award project, but we were part of Show as well. So I agree on the public transportation side, but I mostly agree on fleets, actually. We need to move towards, and that's what Cluster 1 is obviously doing, towards larger scale fleets to be able to really manage more vehicles in more types of different situations in a fleet with remote supervision. And that also comes along or goes along with what I stressed earlier, is to work to further develop the vehicle technologies, including sensors, for example, and computing powers and all these type of things, because we're good, but we're not where we want to be, obviously. So to invest more in that.
Sorry, to make it more specific, because in order for Mats to get it into the work program, he needs to be more specific. What's not good enough yet?
So as I said, we're quite good on LiDARs, for example, but in radars we see that we need to work on more powerful 4D radars. I don't want to get too technical, but 4D radars, mapping, we need more HD maps in order also to be able to scale larger, because if we need to go into every community and city and rely either on our own mapping or on their mapping, we won't really get to large scale, which is very relevant also for public transportation. So for localization, HD maps available on a market would be amazing to have. And then on the longer term, the artificial intelligence for cameras, that would also be very nice to have, but that's a bit further away, I'd say, than better radars and HD maps.
I think you're ticking the boxes for several of the clusters, and not only
Yep.
Mats' cluster number 1. But
sorry about
good.
that.
We work multi-clusteral anyway, so thank you for that. Natasha.
Oh, the pressure is on.
Oh, it's going to be a long list now, Mats.
So obviously it's going to have to be about the user, right? The technology and how that's going, it's not my area, how well it's going, but of course it needs to be designed for the user to understand and to use properly. And also I'd quite like to see an end-to-end journey, even within the three of us, right? I mean, it's not rocket science to think about, okay, if I want to get from A to B to C to D, how do I do that with the high drive and the show, etc., all as one, ideally, so that connectivity of the systems. I think we are going towards more public than private in Europe, the feelings I'm getting compared to the US. But I think, for the individual driver, we've just got to be very careful. I'm thinking about road safety and how many things are in the car and what they do and don't do. So unexpected consequences of technology, just being aware that advanced driver assistance systems can be very helpful, but it can go a bit too far. So don't know if that's the right direction for a work program, but that's
getting some inspiration
like.
can be very diverse. I was just quickly wondering, because you say, I think you and John both say kind of like when we want to move from A to B, would your recommendations be only for passenger transport to scale up in the demonstrations?
So I think we need the lot, right? So again, going all the way back to City Mobile 2 and beyond that, at least what we had, and I don't know how much more advanced they are, sort of 12, 13 years later, the speed at which they travel and where they go is very limited right now. So in order for them to be useful beyond this is fun, we need to think about things like, and I say A to B to C to D, because normally women go from A to B to C to D. Men go from A to B. So thinking about all users, what do they need? How can they put whatever they've got with them in these vehicles? How do they get to the vehicle if they've got a pram or whatever? So, realistic showcases, scenarios that we can think about, at least talk about them. And we've been talking about them when I was involved in STRIA back in whatever it was before COVID. So to make it a reality, to make it acceptable, to make a real difference, I think we need to open those scenarios up and see what can we actually use them for.
Thank you.
That's made it more quiet, isn't it?
Mats, you're satisfied for now? And you know where to find them if you want to dive deeper into these suggestions, right? Oh, that's your action then now.
Sorry, what was that? Sorry.
It's your action. If you want to have more influence, have a discussion, then you go to Mats.
Well, if Mats from Volvo is asking that, then I'll have to say yes, won't I? So, absolutely.
Oh, you're going to be busy, Mats. Yeah, David.
David Storer from Claypa and also Cluster 2 leader, Vehicle Technologies. So it's a really non-technical question, but it seems remarkable when you look at these consortia, how many competitors are working together. I mean, I'm struck by HyDrive, and I know there's a long history of projects, but also the other projects as well. And it seems like a really good basis on which to go forward. And of course, the next step in CCAM is about the large-scale projects that Mats was talking about. So my just general question, is there still the momentum, the interest for these consortia with lots of competitors to go forward and to take it to the next level? I mean, do you see that enthusiasm, appetite still there, or do you think we need to change things in terms of how these things are organized?
Who's taking it on first?
I will just add that I've talked for a while about we need to understand what people are doing in their level 2 and level 3 vehicles. We don't know really on a large scale, and maybe OEMs know for themselves, but I'm pretty sure they don't. Does the driver use the system? Does they know it exists? Where do they use it? We know with some systems, ACC for example, it is adding to safety. We need to know that more about what people are doing in their vehicles. So from where I've been working for the last X years, that is for me something that, yes, there is an enthusiasm just to allow us to develop the right systems for people that saves lives.
I think in the ecosystem, we're a bit moving, how should I say that? We're shifting eras, sort of, because we're going from research and innovation projects to really implementing the technology. So that's why, to me, it's definitely a yes that we should and we have to keep on also to be competitive as an industry to work in these type of consortia, as you say, because that's the only way that we can bring actually, as the session says, the technology on the road, and to have those type of not only large-scale demonstrations, but at some point really implemented in our systems. And I think we're doing an amazing job on European level compared also globally, from what I can tell. So definitely a big yes from my side. And also adding to what I just said about the technology, maybe, and for the cluster 2, working towards software-defined vehicles, we're going to hear about it later. We will need these type of consortia to work closer together, because otherwise this just won't work.
I have to say right now, I'm very happy. Sorry, I have to say that I'm very happy the UK is back in, by the way. Just had to say that, sorry.
Oh, it must have been so painful for a long time. And happy to have you. We do have some youngsters in the room in projects that are maybe not yet presenting this edition, but will do next time. Modi has been mentioned and several others. But what, from looking at the project results that you have so far and how you got there, do you have any recommendations for them? Any traps not to fall into, or any enablers that they should make use of? You're sighing, so I'll start with John. And the microphone would help, yeah.
Let's see.
Yeah, we have the most difficult questions at the end, you know.
Yeah,
You have to remain
no, when my
sharp.
brain is freshest as well, yeah.
It's getting cooked, sorry.
Yeah. I mean, I would say, you know, the advice that I would have for Ultimo, though Lars will know this quite well, is to just get the vehicles on the road. You know, we spent a lot of time in show on all the work behind it. It's always necessary, defining the use cases, the business models, everything like that. But really, vehicles on the road, serving the customers, that's where you learn everything, you know, in terms of the unexpected things, testing what you knew, but really the kind of, the work around, you know, how public transport operators are going to not just put the vehicles on the road, but keep them on the road. All that experience comes from doing it. So, you know, as quick as you can, you know, get it running, and you'll learn so much more than you can from, you know, from the simulations, from the literature reviews, from everything else. That's kind of the big thing.
Thank you. Natalie, any lessons learned for the new projects from the results and how you
I don't know if I'm able to answer that question, since I'm sorry.
I just want to say that it's interesting, about 10, 15 years, I won't name any names, of people testing things in the UK, in the lab, so to speak, came out on the road and said, it's actually much more difficult than I thought it was, which is exactly why we need to test them on the road. So, so that sort of getting the infrastructure, the people, etc., then you'll realize what you're facing.
Yeah, good. I think I have a final question, but before I ask that to you, let's see if there is a question still in the room. Any hand to get raised? You've had time to phrase something. If not, and you feel sorry afterwards, you hopefully know where to find these three people. Reach out to them during the cocktail or at any other moment. I think you're happy to share whatever you can, whatever is asked. Most of it related to the project, at least. The question is, what recommendations do you have for future projects, for future research, maybe policy work, to support the actual implementation of CCAM mobility? So I know that the ambitions of all the three of the projects have been fairly high, but you also know that you couldn't solve the whole puzzle. So where is more work needed and why? What would you recommend for next steps to be made?
I can, just to kind of follow up what I was saying and what Pierre mentioned, the thing that would make life so much easier is just better harmonization of permitting regulation. You know, the reason that it took so long to get vehicles on the road was, you know, more often the permitting than getting the sensors right, than getting the vehicles there. We've had sites held up because, you know, local authorities were looking for data that the vehicles weren't gathering, that had to be retrofitted to produce the data. And when we asked why they wanted the data, they didn't know. They just thought it would be nice and thought it might be useful one day to know these kinds of things. So the sooner we can kind of establish a basic toolkit that, because, you know, it's understandable that these municipalities at a local level are faced with technology that they don't maybe understand, can be quite intimidating. If we can get a toolkit that they can trust, that they know if these boxes are ticked, if they ask these questions, if they get the right stuff, it's safe, it can go on the road, that will make it an awful lot easier to deploy this stuff.
And do I hear correctly, in between your lines, that you would encourage to have a continuous dialogue between the different types of stakeholders? Because
absolutely.
you stressed it implicitly, I think.
Yeah, absolutely. I mean, it's not something that can be imposed on anybody. This, you know, we need to understand the concerns as to what these services are and how they're going to operate. But yeah, anything that can facilitate quicker, safe decision making will make it a lot easier.
And I've seen you, Natalie, already nodding quite much. Yeah. You've had the challenge to maybe add fog and more snow, more rain. But I think you have some other recommendations, right?
Yeah, so I absolutely agree with that. It goes for public sites, for private sites, whatever use case you look at. The education part, basically, to equip people with, you say, toolkit, playbook, whatever, the knowledge that they need to have around that technology is absolutely key at this point. So not just including the users, but also the implementers, if you will. And I had a second point which slipped my mind, but it will probably come back. So adding to that, definitely, yes.
So we go to Natasha, and then if it pops up again, you get it back.
I'm not sure what else I can add, but I just want to second what Natalie said a while back about, I really feel that what has been going on in Europe before CCAM as well, and now with CCAM, is something that US, for example, simply very jealous of how we are doing it. And I think the sort of slowly approach is, again, really to be commended, to make sure it's safe, to this integration across the different stakeholders, and then hopefully more collaboration across. Again, there is a little bit of science there that sometimes is missed. Sometimes maybe going back to basics, checking. But yeah, I think we're doing a really great job, and it's great that it's continuing.
Thank you. Thank you so much. I don't see that you have the big lights. Suzanna, did I miss anything that you wanted to discuss as well? No? Okay, good. Actually, we prepared a list of, I think, about 200 questions, but we realized we didn't have the time to do that. And this is, of course, not the last session of today, so I hope you'll get some energy in the, about 15 minutes that you do have in between now and the next session, which starts at 6:20 downstairs. The plenary session closing today. Well, closing today it's not, because we have, of course, also the cocktail. Afterwards, most of you will be heading elsewhere. And yesterday there was the issue that there was a huge queue in front of the desk to make a reservation for the taxi. So if you're smart, go there in time or in between things and not at the moment you want to leave. Make your taxi reservation in time.
And use public transport.
That's a good one. Or active modes of transport is also fine. Thank you very much. Thank you for being here, for the good questions. And a big thank you for the speakers and for Suzanna as well. Thank you.